So this is the last lesson of the unit. We've talked about several different special quadrilaterals, and they're all listed here. And what we're going to talk about in this section is how to find the area of each one of them. Now, obviously, a square and a rectangle are not new for you. Square is just side squared. You can also look at it as base times height. It just so happens that the base and height are the exact same in a square. That's why it has its own formula as side squared. Rectangle is just base times height. That's something that you have been exposed to since middle school. The new ones, you may have seen a trapezoid previously, but maybe not very in detail. But the new ones are a rhombus, a kite, and then trapezoid. The nice thing about the new formulas is that a rhombus and a kite have the exact same formula. It's just 1/2, and it's diagonal times diagonal. That's what D1 and D2 stand for. Notice that it's diagonal times diagonal, not diagonal plus diagonal. The other one then is trapezoid, which has its own formula. It's 1/2 times the height of the trapezoid times the bases added together. So we're going to come down and we're just going to do a bunch of problems using the formulas given. So number 1 here says find the area of a square whose perimeter is 30 centimeters. So if I know that the perimeter of a square is 30, I know all 4 sides are the same. So if the perimeter is 30, if I only want one side length, I just have to divide that by 4. So dividing 30 by 4 is going to give me 7.5. So one side of the square is 7.5. If I want the area of that square, I'm going to take the 7.5 and square it. If I take 7.5 and square it, we end up with an answer of 56.25, which in this case is letter D. In number 2, it's a rhombus because I have 4 equal sides. I can't assume that it's a square because there's no right angles marked, but they tell me that the distance from top to bottom is 18. That's one of the diagonals. And they tell me the distance from left to right is 18. That's another one of the diagonals. So all I have to do is take 1/2 times diagonal times diagonal. Now, something I noticed in our last unit when we did area of a triangle with trig is that some of you were taking 1/2 times 18 and 1/2 times 18. You were doing like distributive property. That's not what you want to do when it's all multiplication. You just want to multiply straight across. So all you're going to do is take 0.5 and multiply by 18 and multiply by 18. So you're going to get 162 as the area. So you don't want to do 1/2 times 18 and 1/2 times 18. That's not distributive property. Distributive property would only happen if it was plus on the inside. That would be distributive property. That is not what this is saying. So please don't do that. In the next problem, you're given the area of a rhombus. Again, I know it's a rhombus because I've got 4 equal sides. So if the area is 330, all we're going to do is plug in what we know. So I know that this portion of the diagonal is x, so this portion has to be the exact same. And I know this portion is 15, so this portion has to be the exact same. And instead of putting the a in here, I'm going to substitute in the area that I know. That area is 330. So multiplying all of this across, we're going to get 330 equals 30x. That's 1/2 times 2x times 30. And if I divide by 30, we end up with an x value of 11. In the next problem, it says the area of the rectangle is 60 square units. Find the value of x. So I know the area of a rectangle is base times height. So again, we're going to plug in everything we know. 60 equals base of 2x minus 1, and then a height of 1/2 x. So on the right-hand side, that is distributive property because this first parenthesis has subtraction in it. So if I distribute, we're going to get x squared minus 1/2 x. And then we're going to solve by doing the quadratic formula because this is a quadratic. So just like we reviewed in last class, if you subtract 60 from both sides, that's what you get. And it's now in what's called standard form. So ax squared minus bx minus c. So all I'm going to do is plug everything into quadratic formula. 1/2 plus or minus square root negative 1/2 squared minus 4 times 1 times negative 60 all over 2a, which is 2 times 1. So as long as you remember the quadratic formula, now all you have to do is plug all of that stuff in into the calculator. So I'm going to go to my calculator. Let me clear all this stuff. So we're going to go to make a fraction, and it's 1/2. You can't do plus or minus in the calculator, so I'm just going to do plus for right now. We'll do minus next. We have negative 1/2 squared minus 4 times 1 times negative 60 all over 2 times 1. So we get one answer of 8. Now if I want the second answer, I'm just going to highlight this, and this calculator will let me just edit that, and we need to do the minus still. So I'm just going to change that to minus. Oops. And we get a second answer of negative 15/2, which is negative 7.5. So of the two answers, since we're in geometry, we're going to take the positive answer, which would be 8. So I'm going to come back and I'm going to say that my x value is 8, because the negative 7.5 doesn't make sense to have a negative length in geometry. So coming back up, the value of x would be letter E, 8. On the bottom down here, bottom says you need to buy paint so that you can paint the side of the barn. It wants to know how many gallons you have to buy. So the first thing I would need to do is find the area of this, the side of the barn. So the first thing I'm going to find, is the area of the rectangular portion. That's easy. It's just 18 times 26. So finding the area of that, 18 times 26, gives me 468. So that's just the rectangle part of the barn. Now I need to find the area of the triangle portion. So the way I'm going to do that is I have to figure out what these side lengths are, because I don't know what they are. But I know that it's a 45, 45, 90 triangle because it is an isosceles right triangle, meaning that these legs are just hypotenuse divided by root 2. And I'm just going to change that to a decimal. So 26 divided by the square root of 2. And I get a decimal of 18.4. So if I want to find the area of that triangle, it's 1/2 base times height. The base and height are the exact same thing. Just like above, don't multiply 1/2 times 18.4 and then 1/2 times 18.4. Just 1/2 18.4 times 18.4. You get 169.3. So if I want the total area of that barn, all I'm going to do is add those two numbers together. And I get a total of 637.3. And that's all in square feet. So if I want to figure out how many gallons of paint to buy, every gallon covers 350 square feet. So all I have to do is divide this answer by the number of gallons per can. So 637.3 divided by 350 is 1.8. So I need to buy 1.8 cans. Now, not very many places are going to let you buy 0.8 of a can, so that means I'm going to have to buy 2 cans of paint. You're not going to walk into Home Depot and ask them for a 0.8 can. They're going to say you need to buy 2 cans. On the back is where we get into some different figures. The first one here is a trapezoid. So the first thing we're going to do is write down the formula and plug the numbers in. So the height is 10. My bases are just 6 and 12. If I add the bases together, I get 18. Again, this is not 1/2 times 10 and 1/2 times 18. It's just 1/2 times 10 times 18, which is going to give me an area of 90 square units. In the next problem, if I want to find the area of this kite, then I need to know both diagonals. Now, if you look at the problem, I know one of them. It's 20. I don't know the short diagonal. I don't know what those lengths are. But I can figure it out because in a kite, that's a right angle, which means that this purple triangle is a right triangle. So I can figure out that missing length by just doing Pythagorean theorem. So if I do Pythagorean theorem, some of you may already notice what the x value is. It's 5 because it's a Pythagorean triple, which means that this diagonal is 10. To find the area, again, we're not going to do 1/2 times 20 and 1/2 times 10. It's 1/2 times 20 times 10, which gives us an area of 100 square units. Moving down, this trapezoid, we know both bases. We know one base is 15, one base is 31. What's missing is the height right there. So as you can probably guess, we're going to have to use SOHCAHTOA to figure it out. Oops. So let's do that. If I use SOHCAHTOA from the 70, that's opposite and hypotenuse. So I'm going to use sine. So sine 70 equals h over 14. So in order to solve this, I'm going to multiply. So 14 times sine of 70. Doing that gives me a height of 13.2. So that's the number that we're going to plug in here for the height of the trapezoid. So plugging that stuff in the formula, so 1/2 times 13.2 times 15 and 31 together is 46. So I get an area of 303.6. And again, that would be in units squared. In the next problem, again, we have a kite. So I know this and this. So I know one of the diagonals is 24. I don't know the other diagonal. So unlike the last one, we can't use Pythagorean theorem because I don't know two of the sides. But I do know that I have a right triangle in here, and I need to find that piece right there. So we're going to use trig again. So the pieces are, the x is the opposite side, the 16 is the adjacent, so that's the tangent ratio. In order to solve that, we're going to multiply. By multiplying 16 and tan of 40, I end up with a 13.4. Now keep in mind that's only this piece here on top. The other piece is the same. So that entire diagonal would be 26.8. And now all we have to do is multiply. 0.5, 24, 26.8. I get 321.6. In the next problem, it's a trapezoid. So in order to find the area of that trapezoid, we're going to do 1/2 times height times base plus base. So if you look at the problem, the things I know the height is 16. I know one of the bases is 20. I need to figure out the other base. That base would be right here on the bottom. I know that that's also 16. I know that's a right angle. So I have to figure out what that piece is so that I can figure out the whole base. Since I have two sides of that right triangle here on the left side, I'm just going to use Pythagorean theorem. So x squared plus 16 squared equals 20 squared. If you do it correctly, you're going to get x is 12. So that's the second base. And then all I need to do is multiply. 1/2 times 16 multiplied by the bases added together, which is, oops, I'm sorry. That second base isn't 12. That's only a portion of the base. Let me erase that. So what we found here was that part of the base. This portion is 20, which makes the entire base 32. So that should be a 32 in there, not a 12. My apologies. So let's fix that. So 0.5 times 16, the bases added together would give me 52, and I get 416 as my area. Moving down, two more problems. This time you're given the area of the trapezoid, and we're supposed to go backwards and find the height. So let's do that. First thing I want to do is start with the formula. So let's plug in everything we know. Area is 196. Height is x. Bases are 21 and 28. So the first thing I'm going to do here is add the bases together. That gives me 49. And then I'm going to multiply the 1/2 and the 49. Half of 49 would give me 24.5. So in order to solve for x, all we have to do is divide. We get a value of 8. Oops, and this is not in inches, it's in feet. Correct that. The next problem is also a trapezoid. So let's start with the formula first, which I have written here on the left. So 187 equals 1/2 times the height of 17 times the bases added together, x plus 6. First thing I'm going to do is multiply the 1/2 and the 17. Half of 17 is 8.5. You can do two things at this point. We could distribute the 8.5 since it's a plus sign, or we could just divide both sides by 8.5, which is what I'm going to do. If I divide 187 by 8.5, we get 22. So 22 equals x plus 6. And if I subtract 6, we just get an x value of 16. And it would be in centimeters. Moving down, last problem. It says one diagonal of a kite is twice as long as the other. The area of the kite is 72.25. What are the lengths of the diagonals? So if diagonal 1 is x, diagonal 2 is twice as long, which would be 2x. So let's plug everything into the formula. Your formula for a kite is 1/2 diagonal times diagonal. So 72.25 equals 1/2 times x times 2x. The left-hand side stays 72.25. The right-hand side simplifies. 1/2 times 2 is 1, so this is just x times x, which is x squared. So in order to solve for x, all I'm going to do is take the square root. If I take the square root of both sides, I get x equals 8.5. So the deal is that the diagonals are not both 8.5. It's that one of them is 8.5. The other one is 2 times that. 2 times 8.5 gives me a length of 17. So I have diagonals of 8.5 and 17, which would be letter C. Make note of any problems that you have questions on, especially the area ones that involve doing trig first. If there are any questions specifically about any of those, I can always go back over 1 or 2 of those in class. So just make note of that so that you can ask when you get to class.